Can you hear me? Okay, great. So, can we start? So today, we will introduce you something about how we can use Unity to train autonomous vehicle. So maybe it seems strange, because for autonomous vehicle, you think it's related to the autonomous or mechanism or AI, but Unity is mainly about games. Yeah, why it is related. So that's what we need to explain today. And before my talk, make some introduction about myself. My name is Lu Chen, and I come from China, Unity, China. And I graduated as a PhD of graphics. And before joining Unity, I worked for BMW and General Motors for many years. And so my experience covers the graphic technology and automotive industry. Yeah, so you can imagine I like my current job very much. But my point is actually personal, based on my background. I want to say, personally, I will be so exciting for this topic. I mean, to use Unity to train the AI or train the autonomous vehicle. Why? If you look at, for example, if you look at all the other presentations today, I think the content generated from Unity or graphic engine was mainly served for human, right? Because they generate the graphic content and serve for the human eyes. But in our talk, it is serve for the AI, for the machine. So I think that is actually open a door to a new world, not just for Unity maybe, but also for the whole graphic society. I think it will bring us a lot of chance and force. Okay, so let's start. So today, we will address the following questions to let you know why we need the simulation, and how simulation will be used for autonomous vehicle development, and of course, how Unity can help here. Okay, so I assume maybe not all of you know much about the autonomous vehicle industry, so I will introduce some background knowledge first. Hope it will still be interesting to you. Talking about the autonomous vehicle, maybe someone said, okay, yeah, it's just the car can drive it by itself and without driver. That's true. But frankly speaking, we cannot go this goal directly. So it will be step by step. So here's levels, depending on the automatic degree. And for level 0, yeah, manually. And level 1, some automatic, like SCC, adaptive cruise control, belong to level 1. Level 2 will be more smart, and it can help you to change the lane or brake. And yeah, actually nowadays, the intelligent vehicle production currently belong to the level 2. For example, Tesla autopilot is also belong to level 2 actually. Start from level 3. This will be much different. The difference is that under some situation, for example, the highway or traffic jam, the car will do all the stuff. And maybe sometimes it will give you signal, and you will be handed over to handle some problems. But under most of the time, the car will need to handle all the things by itself. For L4, it will be even further for most cases, for more situations, and you can even ignore the notification and do not have to handle that, but the car should guarantee it is safe. For level 5, yes, it's fully automatic driving. Why I introduce this? Because I want to let you know we are just in the gap between level 2 and level 3. And it's actually a bigger gap. Why? Below level 2, the critical problem is solved by humans still. The car is assist. So it also means that when it crashes, the human, the driver, will take the responsibility. But above level 3, the car, if crash, the car will take responsibility. Or you can see maybe the car companies. Maybe that is also one reason why we cannot see L3 cars driving on the road today so far. Yeah, so you can know the difference. And the difference also determines the the criteria we validate the quality. Below level 2, you can just enumerate all the cases the car should pass. So let's say, actually, simulation is not very new for autonomous vehicle industry, but for below level 2, it can just focusing on some fixed scenarios. For example, you have, for ADAS, you can have about 1,000 different scenarios, and let your car to just add some examination to pass the one by one. If all scenarios passed, it is qualified, because the situation and the scenarios can be listed. But for above level 3, because the real world is so complex, so it's actually it's impossible for you to enumerate all the scenarios. So here, we need a more powerful simulation platform to support this new requirement, to have some new technology to can generate more complex scenarios in a very efficient way. So that's why we need Unity here. Okay, so next, I will do some brief introduction about autonomous vehicle system. So it's a typical autonomous vehicle system, including these components. We start from the bottom, that's perception. So just as human to see the world, the car needs to perceive the surroundings using the sensors, camera, LiDAR, radar, GPS, MU, blah, blah, blah. And through this, it will know where it is and what the surrounding objects are. After they know this, it will do some planning. So what's the next? Which way to go? Or if I need to change a lane, something. So basically, to plan the trajectory. Sometimes we also use coordination. Means sometimes, besides of the information, the perception information from the car, we also get information from the other side. We call the V2X technology. V2X means V2V or V2I. V2V means, for example, the car in front of you can send you a message, send your car a message, okay, to say, okay, I will stop. And the V2I means maybe you have some sensors at the roadside, and it already detects 200 meters ahead of you have some accident. So it can send the information to your car, and it will impact your car's planning. After we have planning, the control component will implement that by controlling the car to implement the planning results to finally achieve your goal through the steering and adjust the speed. Okay? As you already realized, the core of the autonomous vehicle should be based on the AI or machine learning, especially for the perception and the planning module. It will highly rely on the machine learning. And here is the typical process for machine learning training progress. So we start from collecting data. You have a car, drive on the road, and to take data, let's say, for example, image. After you have so many images, first you need to do annotation. What is annotation? Because the AI algorithm sometimes needs your input. We call it supervised learning. And you need to tell the car on this image what is the pedestrian, what is the car, what is the road, through this kind of red box in different color to indicate different semantic meanings. And after you have this annotation information with the original image, you split them into two groups, training set and the testing set. Training set is to teach or to training the model, the AI model, to let them know to identify the objects. And the testing set is for the test. So hopefully, if we pass the test, it is good. If we didn't pass, okay, we go around again to adding more data and to finally achieve the recognition rate. And as you may imagine, the annotation work should be very time-consuming, and it or depending on the human. So let's say machine learning could be the core of the autonomous vehicle, and it depending on large amount of data. Collecting data is expensive. What is worse is annotating them is even more expensive and error-prone. So human, because we depend on human to label the data, and the human can make a mistake. But how we can check out the mistakes? Maybe arrange another human to check it. So you double the price, double the cost, okay? But it is still not the worst thing is, because the real-world data has limitations. It can only reflect the scenarios that already happened. Just as the image shows, people always think, I have already seen many things, for all the things, but actually there's always something behind you. This is some video recorded on the railroad, and you cannot imagine what kind of stuff can show on the road. For example, a man sitting on the cart, a tank, even a helicopter. And for this one, actually, I don't know. Maybe it's a very good drivers, but I'm sure this will be filled on the most predict algorithm because it's definitely so strange. Okay, so why simulate? Why we need simulation? The first thing is the simulation can generate unforeseen scenarios and edge cases for us, which are very extremely hard to collect in the real world. And second, of course, we can generate it in a very efficient way. For the simulation workflow, first, you need to have some static environment. Yeah, it's not hard to imagine. You need to build the road model. You have the road model, road length, and the signs, the buildings, trees. Yeah, anything cannot move here. And you also add some dynamic things based above that. You add pedestrian, you add traffic, you add different weather effect and the time of day effect. Yeah, so dynamic part, or we call the scenarios, is very important to generate the edge cases. After you have the virtual world, we still need to have something to consume the content. So we need to have some sensor models to generate the census data from this world, to generate the census camera signals, LiDAR cameras. This data will be passed to the AV system. And in order to pass them, we also need to implement some protocols to connect to the AV. And we also can integrate AR and VR for visualization. On the right side, right column, here are some applications which our simulator can be used for the AV industry. Of course, our data can be used for model training, and for the validation, for the testing, and also for the certification. It's from government organization give you license for testing your product if it's qualified. Also, it can be used for data visualization because sometimes as a human or engineer, you want to check what is happening and figure out the underlying logic. And the green box things are suitable for the Unity. The Unity is good at creating this kind of content. Actually, we are finding Unity is becoming more and more suitable for the simulation. For example, we have this kind of scriptable rendering pipeline. It's not just means we have high-definition rendering pipeline which can produce realistic image, which can use for camera simulation. But also, this kind of customized rendering pipeline will be very useful to simulate other sensors. I will introduce a little bit later. We have dots, which makes us more suitable for very large thing, very large city, and with very complex traffic system. We have environment toolkit, can make you to do some procedurally generation, large terrain, and different rendering effect. We can support different physics. Of course, the editor is always our advantage. It will be very efficient to conduct very dynamic thing in Unity. Also, we support machine learning frameworks. I think for the next section, my colleagues will introduce you some detail about that. But anyway, so all the features makes us think Unity is actually more and more suitable for simulation. That's why the autonomous vehicle industry has proactively adopted Unity already. Let's see, here is some sensor simulation results. This is for the segmentation simulation. Just as I said, this work is equivalent to the manual labeling. And here, we use some special shader and to generate this kind of segmentation result. So different objects using different color. So it's totally automatic and without error. Okay, this is for the LiDAR simulation. Yeah, where's the LiDAR? Okay, sure. If you know some principles of the LiDAR, it will like some from some point to shooting out many laser beams. Or usually, calculating these kind of things is very time-consuming. But in Unity, you can leverage the depth buffer to do a great acceleration for this kind of computing. Can anyone guess what is this? What's that? What's the sensor? It's actually thermal infrared image. Yeah, as you know, that is very important sensors for vehicle if you want to drive it at night. And here is the simulation result for the fisheye camera. It will be so realistic, even with some artifacts on the lens. And here is an example for showing the company using our Unity to do the planning simulation. So they use Unity to conduct a very dynamic traffic situation to test their planning system. Yeah, here is the LG's simulator, which I demoed in the morning for the opening note. It actually leverages many Unity latest technology already. It creates so realistic thing, and it actually supports, I think, many functions to the autonomous vehicle developers, including the sensors, but many things. So it will be really quite advanced. So one of the most important roles for Unity is actually to maintain an ecosystem for this. So here is just a selected list for the companies who have already used Unity to do the simulation. Some of them do focusing on the parts of them, for example, the sensor simulation. Some of them doing the whole simulator, like OEMs and LG. But I want to say, as Unity, our purpose may not be build the simulator by ourselves. Our purpose is always to support our customers in many aspects, to help you to build the production and the simulator on your demand, and to supply the technologies, and even we can do some cool development together to help you to build your production. So we have SimViz project. What is SimViz? SimViz is a combination of simulation and visualization. And they are actually the main applications used in autonomous vehicle industry for Unity. And the purpose of SimViz is actually SimViz is a package including all the features and the functions which we think is useful for support the simulator development. Let's see the simulation system another way. So for the left part, here is the autonomous system I already introduced. Please note that could be software or even some real hardware, including some chips or a car. So you just need to connect to our simulation environment. In the simulation, you need to have an environment. Here, the environment including the static elements, the dynamic elements, and also the global parameters to adjust the time and the weather. So once you have the environment, you can generate different scenarios. After having that, you will have a sensor model to generate the census data to pass over to the perception module of the autonomous system. And we also need to have vehicle dynamics to get the output from the control and to get this kind of circle. And Unity and SimViz will do works in this area, which we were good at. So, how Unity SimViz can help the autonomous vehicle development? The purpose is actually we want to encourage more and more companies and developers to join this simulation development. And we also want to lower the barrier and increase the ROI for some companies to help them to build the simulation in much easier and efficient way. So as a roadmap, SimViz will start from content sensors integration, this part, and to try to lower the barriers. But we will continue our developers and to focusing more on the scenarios, to solve the scenario generation, the scale problem, which will be higher value for the industry. So for now, the SimViz can supply these three aspects support. First, content. Yes, we always to help our customers to generate the content or get the content very efficiently. Actually, I think one of the most advantage of Unity is our community. If you look at as a store, there's already many resources and tools you can leverage to create your world. Such like this easy road, you can use that to generate those things very efficiently. And this one you can use for the sky and lighting illumination simulation. We also include 3 artificial things for the starters. For the starters things you can leverage for your beginning your simulator work. And it covers urban, suburban, highway, which are very typical things for the autonomous vehicle development. And here is the video for showing one of our things. You can see in our demo scene, there is content. First, its work can be rendered in very high quality, very realistic, and it contains many different type of road and junctions, and also the city has many, many details which will be very close to the real thing. And of course, we will supply the sensor models. In our package now, we include all the common sensors you can use for the autonomous vehicle development, like camera, LiDAR, radar, MU, and GPS. Of course, you can always replace them with some more advanced one, or you write your own one, but yeah, we just supply this for reference and starter. For the integration, we always want to solve the problem how we can connect Unity to the autonomous vehicle society. Like we support the ROS link, and we support the OpenDrive format, something like that, to help you to easier to connect the Unity and the Unity data to the autonomous vehicle industry, existing solution or existing software. And what we want to emphasize is we supply this kind of cloud-based simulation platform, which nowadays, based on the Google Cloud Computing, we can run millions of different simulation instances at the same time. So for running one task, for example, if you run on one desktop, it could be run over 100 years. But if you run on cloud, it could be shorter than 1 hour. That will be very, very efficiently for the autonomous vehicle development. So if you want to know more details about SimViz, you can always go to our website and or contact with our colleagues. So just as I said, the SimViz is still under continuing development. And also, our purpose is to help you to conduct your simulator or your work in this area. And yeah, we can do, we also would like to join your department also. So it seems that I finished too early. maybe for some questions. Thank you.